differential positioning. In differential positioning, the principle is similar with relative positioning. We have 2 points A and B, and point A has already a coordinates. So it means that we have a point with known coordinates, and we put an instrument, a GNSS receiver, on that point and determine the coordinates of the point again. And we expect that the coordinate that we get from the point A is the same with the coordinate that we already had for the point. So therefore we observe coordinates, we already have some coordinate. The difference between them shows that how much the system can work. Somehow it's like an error equations for them. And when we determine the coordinate for point B, we can send the coordinate differences that we have computed at point A to the point B as corrections. And when we added these corrections to the point coordinates observed at point B, we correct the coordinate. This principle that I have explained is said differential positioning in coordinate domain. It means that I determine the coordinates and correct the coordinates. But it can be done in another way. It can be done in measurement domain. It means that I use the coordinates and regenerate the observables or the observations and correct the observations. And at the point B, I correct the observations at the point B based on the corrections that I have already determined at point A. Then use these corrected observations to determine the coordinate for the point B. Differential positioning can also be done using code and phase measurements. So of course phase measurements are more precise, and we can come to a good quality for the coordinates when we use phase data and when we use a measurement domain. One point that should be considered, the point B should not be so far from point R. When it is far there, the corrections are not that valid anymore for point B. Also, we assume that we observe the same satellites over those points. So, which is a rather hard condition. We always can have one satellite come in, maybe, or one satellite goes out of the horizon. So we may have problem then. But in that case, we can somehow approximate the coordinates of point B. So it is very good when point B, or the unknown point, is close to the known point. Differential positioning can be done over a large area as well. What I have explained before, but for one point. What if we have a network of points and they already have coordinates determined by other methods? We can put instruments or GNSS receiver at these points that they have already coordinates and determine the coordinates again, and the differences are sent to a responsible authority, and they are responsible to analyze the coordinate differences, the differences between what GNSS gives and what we already had as coordinates, and they will realize how much corrections they should provide to the user. For example, if I want to work at this point here, and I need a reference point here, but I don't have any reference to get corrections. So By using the code measurement, I can determine or approximate the coordinates of this point immediately by the receiver and send them to the responsible authorities. The coordinate goes to the responsible authority, and this authority computes the corrections for me and send it back to the place that I ordered to the receiver. So I have the corrections. It is similar to this fact that I already have the reference stations because I needed the reference station to get these corrections. But if I have the corrections from other sources, it is similar to that. I have a reference station, but it doesn't exist practically. So I have a virtual reference station. So as I explain again, I already have the corrections. I need the reference station just to compute the corrections. But if at any point I can get these corrections from the responsible authority, then I can say that I have a virtual reference station. So this is a station which does not exist, but I have the corrections.